Dear students, we all know that the life on this planet Earth is only possible due to the presence of water. All the forms of life need water for their existence. Human body is made up of 65% of water. It is the most abundant and most essential compound, and it is also most easily obtainable chemical compound. We cannot think our life without water. It is such an important chemical compound. So today let's study the structure of water. Water is made up of two elements, hydrogen and oxygen. Oxygen, atomic number 8, electronic configuration 1s2, 2s2, 2p4. It has 6 electrons in the valence shell. Hydrogen, atomic number 1, electronic configuration 1s1. Now you can see that the 2 hydrogen atoms and 1 oxygen atom. These dots are valence shell electrons. We say it as electron dot structure. Now you can see that each hydrogen atom is with 1 valence electron and oxygen atom is surrounded with 6 valence electrons. Now the chemical bonding will take place and a covalent bond will be formed between hydrogen and oxygen by the sharing of electron. Now from this structure you can see that this pair and this pair is a shared pair and it is a covalent bond. In addition to these shared pair of electrons, there are 2 lone pairs on the oxygen, 2 bond pairs and 2 lone pairs. Now there will be lone pair repulsion and lone pair bond pair repulsion. Due to these repulsions, the shape of the water molecule will be distorted, and we say that the shape of the water molecule is bend shaped. Now I am showing you through the molecular model kit. This is the water model. The red ball here is representing oxygen atom and these 2 white balls are representing hydrogen. Oxygen is covalently bonded to these 2 hydrogen atoms via covalent bond. On this oxygen there are 2 lone pair of electrons. I am showing these 2 lone pair of electrons using these blue lobes. Now you can see this. This is the water molecule. There are in total 4 electron pairs, but out of these 4 electron pairs, 2 are bonded and 2 are lone pairs. Now there will be a repulsion between these 2 lone pairs and lone pair and bond pair. Due to these 2 types of repulsions, that is lone pair repulsion and lone pair bond pair repulsion, the water molecule will have a distorted shape, and this shape is known as bend shape. Due to this distortion, the HOH bond angle is 104.5 degrees. Now I am comparing this water molecule with a regular tetrahedron. Actually what happens when there is 4 electron pair around the central atom, then and all the electron pairs are bonded, then it takes the shape of a regular tetrahedron and the bond angle is 109.5 degrees. But in the case of the water, although there are 4 electron pairs, but out of that 4 electron pairs, 2 are bonded and 2 are lone pair. So the angle reduces in the water from 109 degrees to 104 degrees, and the shape also is distorted, that is from the regular tetrahedron to the bend shaped. Now we also know that oxygen is more electronegative than hydrogen. The electronegativity of oxygen is 3.5 and that of hydrogen is 2.1. Due to this difference in the electronegativity, there is a dipole in the water molecule and the value of the dipole moment is 1.84 dBi, D for dBi, and the water molecule is polar. Let me show you through the slides. Now you can see in the slide, there are two hydrogen atoms bonded to oxygen, and through the blue dots you can see that these are electrons, the two lone pair of electrons on the oxygen. You can also see the negative charge on the oxygen and the plus charge on hydrogen. It is because of high electronegativity of oxygen than hydrogen. Due to this high electronegativity, actually what happens? The shared pair of electron shifts towards the oxygen and oxygen acquires partial negative charge and hydrogen acquires partial positive charge. This figure also very clearly shows that how the two electron pairs which are shared between the oxygen and hydrogen are shifted towards oxygen, and the bond is polar covalent bond. You can see the water molecule as a dipole. The bent structure of water is very well seen on the slide and the bond angle 104.5 degrees. Now I am showing you the hydrogen bonding in the water. Oxygen is tetrahedrally surrounded by 4 hydrogens. With 2 hydrogens it is covalently bonded, and with other 2 hydrogens there is the hydrogen bond. Now you can very well see from this structure that these solid lines are the covalent bond and these dotted lines are the hydrogen bond. This is one molecule of water, this is another molecule of water. Oxygen of one molecule of water is bonded to hydrogen of another molecule of water via hydrogen bond. You can very well see from the other molecules also. This is again a water molecule, this is another water molecule. Hydrogen of this water molecule is bonded to oxygen of this water molecule via hydrogen bond. The hydrogen of one water molecule is bonded to oxygen of another water molecule through hydrogen bond. Now you can see from here that this oxygen is surrounded by 4 hydrogens, 2 via covalent bond and 2 via hydrogen bond. This extensive hydrogen bonding in the water molecule is responsible for its very high boiling point. The 16th group elements: oxygen, sulfur, selenium and tellurium. All these elements with hydrogen form the compounds H2O, H2S, H2SE and H2TE. But the unusual properties of the water is just because of the presence of intermolecular hydrogen bonding. The unusual higher boiling point of water as compared to H2S is only due to hydrogen bonding. Another important property that water at room temperature is liquid, but H2S at room temperature is a gas. It is again also due to the presence of intermolecular hydrogen bonding in water. Hydrogen bonding in ice. In ice you can see that so many water molecules are aggregated and hydrogen bonds are also here. But in the case of the ice, you can see the wide vacant spaces. These are the open structures in the ice. These open structures are responsible for the density of the ice lesser than water. It is a very important aspect of ice that its density is less than water. In everyday life, we see that in all those cities and countries where the temperature goes below 0 degrees Celsius, that is the freezing point of the water, the ice floats on the water. The water on the surface freezes and it floats on the water, and the water beneath that ice remains in the liquid form. Ice floats on the water's surface. It is just because of these vacant open spaces in the structure of ice, which makes its density less than water. It is very important because it ensures the aquatic life comfortable in the winters also. Let me show you all this through the slides. Hydrogen bonding in water and ice. Because of the polar nature of the water molecule, the water molecules are held together by intermolecular hydrogen bonds. Now you can see the hydrogen bonding. Oxygen is shown by the red balls and the hydrogen is shown by the greyish blue balls. The dotted line is showing the hydrogen bond. You can see that the red ball is bonded to the blue ball of the another water molecule via hydrogen bond. This is intermolecular hydrogen bonding. Inter means between two molecules. The bond line formula also you can see at the bottom, which is showing the hydrogen bonding in water. Extensive three-dimensional network is present in water. Each oxygen is tetrahedrally surrounded by 4 hydrogen atoms, 2 by covalent bonds and 2 by hydrogen bonds. Ice consists of aggregates of varying number of water molecules held together by hydrogen bonds, but ice has open structure. Due to the large number of the vacant spaces in the ice, the density of the ice is less than water and ice floats over it. This is the structure of the ice you can see on the slide. You can very well see the open spaces, the cages or the vacant spaces responsible for the lower density of ice as compared to water. This is again a figure showing the extensive hydrogen bonding. This is again a three-dimensional view showing the hydrogen bonding in water, which is responsible for its unusual higher boiling point and other properties. This you can see ice floating on the water. That ensures the aquatic life. Now I am telling you the two important properties of the water. Holding it together. Consider a glass of water. Why do the water stay together? The answer is the hydrogen bonding. The intermolecular hydrogen bonding is responsible for holding the water molecules. You can see the formation of the covalent bonds. These are the intramolecular forces between the atoms. The blue arrows are joining or connecting oxygen with the hydrogen. These are intramolecular forces. Now you can see the intermolecular forces occur between the molecules. The intermolecular force means the forces between two different molecules. These intermolecular forces are responsible for holding the molecules of the water in a glass of water or in a bucket or any of your container. Now next thing is why oil and water don't mix. It is a common day experience that when we mix water and oil, the oil forms a separate layer and it floats on the water. What is the reason behind this? Let's take a look at why oil and water don't mix. Because oil is non-polar and water is polar. The yellow drops or the yellow circles are the oil droplets and the water molecules are shown by pink and blue balls. Now you can see that in between the water molecules there are oil droplets, but after some time we can see that this oil will come on the surface. What happens actually is there is attraction between the opposite charges. Hydrogen is having the positive charge and oxygen is having the negative charge. Now you can see that slowly the oil droplets are coming out of the water molecules and water molecules are making the separate layer and the oil droplets are making the separate layer. Now you can see in the figure 3, just because of the electrostatic attractions between the opposite charges, the water molecules, they are aggregated together and the oil droplets are out of the water and they form the separate layer. So we can say that the opposite nature of the water and the oil droplets, because oil is non-polar, there is no separation of the charges, but water is polar. There is a separation of charges because of the high electronegativity of oxygen. Due to the difference in the nature of the two liquids, they form separate layers. They are immiscible. Dear students, today we have learned the structure of the water and its unusual properties due to the presence of intermolecular hydrogen bonding. We have studied why ice floats on the surface of the water and why oil and water do not mix. I hope all these things are very much clear to you. Thank you.